Assalamualaikum warahmatullahi wabarakatuh and good day everyone. So I am Dr. Siti Nur Rafida binti Duso from School of Civil Engineering UTM. So this is SEAA 1713 for soil mechanics. Okay, last week we already covered some of the soil mechanics introduction including the geotechnical engineering. So I hope you still catch up and remember that the soil is actively biological matrix. So we have a O horizon, A horizon, B paramaterial, and lastly the fresh rock, or usually we call as a bedrock. Okay, so C horizon and also arc horizon. So as I mentioned last time, soil is particulate material. I just want to recap again the last week teaching because in this way, I would like to go for the soil basic properties, the soil composition. But before I go there, I would like to highlight that the soil has two different types, which is transported soil, which it originate from other site and redeposited to the other's place. So it can be alluvial deposit, aeolian deposit, glacial deposits, and the agent of transportation is follows its type. And another type of the soil is of course residual soil. So the soil that is originate there comes from their parent rocks, uh, like this one. So originally it is a rock. Total million years ago, maybe the whole site is rock. But however, due to the weathering process, mechanical or chemical, so it becomes differ. It becomes paramaterial, partly weathered rock, and then slowly it becomes subsoil and so on. So um, transported or residual soil. If it originates there, so it is a residual soil. Okay. So let's jump to the last slide. I just want to give a big picture on the soil mechanics. So next in our courses, so we will see how the soil mechanics, especially their composition. Why we in next chapter actually we want to see the soil composition. Why? Because we want to understand and to have a control, as the soil is highly variable and we of course have a very little control that the soil is heterogeneous material. So in order to control them, that's why we need to understand the soil basic properties or the soil composition. What the inside the soil what we have. Okay, and of course when we're dealing with the mechanical properties of the soil, so we can apply to solve the engineering problems such as deformation and knowing the strength of the soil, knowing the interaction with the structures, foundation materials, knowing their stability and serviceability, and of course interaction with the water. So let's move to the next slide, the soil basic properties slide. Okay, so this is the slide of soil basic properties, soil composition. So bear in your mind that we learning these all equations to understand the soil properties and to help us to control this material in the future when we want to use as a foundation, when we want to use as a interaction with the retaining wall and so on. So the soil usually can be divided into three components. Let me use the laser. So three components, and the three separation of the soil is taken as a three-phase system or three-phase diagram. Okay, note that in the previous slide, I mentioned that the soil can have uh, even can have bacteria in it, fungi, and so on. But for the engineering purposes, we only consider three components in the soil, which is soil solids, water, and also the air. So this is how the original soil skeleton might look like. So we have a soil particle, solid particle. We might have a void, which void is consists of water and also air. So air, water, and solids is a three-phase diagram. And the three-phase diagram also known as a partially saturated condition of the soil. Means not all voids in the soil is filled up with water, but only partial part of the voids in the soil fill up with water. Okay, next we can see at the side, this is two different types of soil condition, the other condition of the soil. One is fully saturated, so the voids in the soil is fully with water, or either the next one, the void in the soil is fully with air, and it is called as dry soil. Dry soil. So in the soil only have solids and air only. For fully saturated only have solids and water, no more air. Okay, and before we go to the equations, please note that all the notation is a standard one. So M is for mass, W is for weight, V is for volume, sub S is for soil grains, sub W is for water, and the rest. So we can firstly produce the volume weight relationship or volume mass relationship. So let's see how. So this is three-phase diagram. We start with the three-phase diagram first. We doesn't no need to see the fully saturated and dry yet. Later on we go there. So for the three-phase diagram, of course, we have volume in meter cube, also weight in kilonewton. So this is V sub A, volume of air, volume of water, V sub W, and V sub S, volume of solid. And the total of volume of A, volume of water is volume of voids. And of course, all of the volume is volume total. Similarly, for the weight, W sub A or equal to 0, weight of air usually doesn't have weight. So W sub W, W sub S. This W is capital W. Similarly, for the volume, is a capital V. Capital V. And sometimes it doesn't denote the measurement in kilonewton. So sometimes in laboratory or in field, engineers or technicians use the kilogram, the mass. So we also can have MA, MW, MS, and MT, total mass of total. So note that this is also a capital letter. MS, MW, MA. M is the capital one. Okay, I skip this. So the relationship between the weight and between the unit weight and the mass to the volume is unit weight for the system that using kilonewton, and also the density for the system that using the kilogram as the measurement. And this one also known as a gamma bulk and density of bulk, raw bulk. So how to spell bulk? See. So bulk means you have both water and air in the soil. Okay, this is also B. Short form is B, but the full is bulk, bulky of soil. So means gamma bulk or rho bulk is the soil in three-phase diagram. They have water and they also actually have air because we have a volume of air. Okay, the void is filled with the water and air. Similarly, void is filled with water and air. So gamma bulk. Later we can see gamma dry, the dry state of soil, and also gamma saturated. Okay, so density can be addressed. Similarly, density and unit weight can be addressed in the bulk, in saturated, and also dry, and also submerged. And the relationship between gamma and rho can be addressed by using gravity. The gravity, relationship between the gamma and the rho, the unit weight and the density is by times the density with the gravity. Okay, so that's the first part. Okay, now we start to produce another equations that we have in the basic relationship. So the next one is the void ratio. If I could show you first the porosity and their relationship between the void ratio and porosity. So sometimes I also always call them as a siblings. The void ratio E and the porosity is a siblings to each other because they are defined quite similarly. So what is void ratio? So void ratio is the volume of voids, this part, divided by the volume of solid, ratio to the volume of solid. So how much the voids compared to the solids. And for the porosity is how much the volume of voids compared to the volume of total. So sometimes they are addressed in the percentage, but usually they are addressed in the decimal point. And E is not limited to 1. It can up to 3.5, 4, depends on the soil condition. The stiff clay could be 0.6, but the quite loose clay, it could be reach 2.4 up to 3.5. Let me check first. And okay, it's okay. Later I will show you the value of the void ratio. Okay, organic clay. Okay, organic clay sometimes 2.5 up to 3.2 means it is quite loose. If the lower the value, the denser actually the soil. And okay, the significance of knowing the void ratio for the particle movement in the soil. For the loose particle, the higher value of E, So the soil particle in the higher value of void ratio can move quite easily, and opposite for the denser one. For the fluid conductivity with a high value of void ratio, we're showing very high conductivity means water easily pass through between the soil particles. And for the volume change tendency control, if the soil is having high void ratio, high void ratio, loose soil, the voids in the soil skeleton is tend to become minimized under the loading. So maybe we encounter the settlement.